All right, so we come to the continuation of the topic on calculations. Now, so we come to the calculations today. Now, our focus for today is to get used to some more practice on doing the calculations on direct titration. Okay, so this is you may refer to page 124. This is a very authentic question. Now take a look on the questions. On question 1, first of all, tartaric acid is a dibasic acid, so found in many plants. A solar sample contains tartaric acid and other soluble inert substances. Inert, which means no chemical change. 2.0 gram of a sample were dissolved in the ionized water and diluted to 250.0 cm³ of the solution. Portions of 1/10, okay, 1/10 portion, which is 25.0 cm³ of the solution was titrated with, now take a look on the term, titrated with 0.122 molar NaOH, using phenolphthalein as an indicator. Finally, the average titer is 19.35 cm³. Is used to reach the endpoint. So the name, so the question comes. First of all, name the piece of apparatus which will be used to add NaOH to the acid solution before titration. What is that? What is that apparatus? What is that apparatus? Added is used to contain NaOH, and it is added to acid during the titration. So what is the apparatus? Tam Guan Yao, are you here?
Yeah.
Tell me what this is.
Conical flask.
Conical flask. Now take a look at the word. 25.00 cm³ of solution was titrated with NaOH. So what you may imagine, right, will be this setup. So the question comes, NaOH, where is NaOH?
My paper filter.
Burette.
Yes, that's right. Burette.
25 cm³ burette.
Yes, 25 cm³ burette.
佢話加19.35㗎嘛。
Hi, now take a look on this. The physical quantity stated is a very high precision, 19.35, okay, which means that you need an apparatus of so many grating with the difference 0.1 cm³. Okay, so this is burette. Burette is the choice. Okay, so the NaOH is here. Only by putting on here would they have a volume as accurately measured as 19.35 cm³. Can you get a point? So this is NaOH on top. How about the one at the bottom? What is that? Now at the bottom it is we have got 25.00 cm³. This one of solution. What is this solution? What do you mean by that? That is a tartaric acid solution, right? It's found in the solid sample dissolved inside. Okay, so it contains the solid sample dissolved. Okay, dissolved solid sample. containing Titrations. But remember, it's just 1/10 of it. Okay, originally we have got a solid sample, but finally I just extract 1/10. Now from 250.0 cm cube, I get 1/10 for testing. So which means that we have got 0.20 gram of the sample dissolved in that solution to make it to 25.0 cm cube. Okay, you get my point. Together with the indicator phenolphthalein. You get it? So the question, how would you deliver that 25.0 cm cube of a solution? Is by pipette. It's by 25 ml pipette. But for the burette, it is used to contain NaOH. Okay, you get my point. So the clue is you can check the number, the decimal place, what is that figure, and you can get to know more about the choice of glassware. Can you get my point? If it is all those just zero, it would just have one great line. We call it graduation mark. So pipette is just a choice, okay, for to deliver 25.0 cm cube of a solution. How about 19.35? Mine is of very high precision. So it is, you think of a grating as close as 0.10 cm cube of the burette, okay? So the burette is a choice. Can you get my point? And three, the third item that you may see is the word were titrated with or were titrated against. What is meant by word titrated? Titrated means 滴定. So what is mean by 滴定? It means that added drop by drop. So the one which add drop by drop into the other one. Okay, so you are going, what is the meaning? The solution on top, okay, would titrate with the of the exit. In other words, we will call that the exit was titrated against the alkaline. Can you see the active voice, passive voice? 明唔明我講咩？上面滴落去啊嘛，咁所以咧下邊嘅酸嘅溶液咧就被滴定啦，所以就 were titrated with 或者 were titrated against。所以留意下呢啲字，係官方寫法啦 ，were titrated with、were titrated against 後邊嗰嚿嘢咧就放咗喺 burette 度，得唔得？你都唔肯定嘅話，你就望數字。如果個數字係有小數點，但係唔係零嗰啲咧，咁好準啊，.35啊、.55啊、.50啊呢啲咧，就一定係 burette 啦，係嘛？因為你唔會有嗰啲pipette啊，其他嘢咧全部係讀.0咧.5噶嘛，咁啊.00嘅啫，人哋讀。跟唔跟到？好，第二點啊 ，state the expected color change at the end point。因為我寫咗呢個咧就易諗啲啦，原本係酸啊嘛，酸嘅顏色係咩？
colourless 啊，
係原本 colourless， 跟住點啊？
變咗 pink 咯。
Yes, it is from colourless to pink. All of you please back it down. It's from colourless to pink. Why is it from colourless to pink? Now it is this is the choice of the indicator that affects our answer. 記唔記得個 choice of indicator 嗰個版喺後邊嘅？ Choice of indicator. So tartaric acid is a weak acid. I titrated against the strong alkaline. So that the case which is quite similar to this on page 128. So the equivalence point would have the pH higher than 7, which means the neutralized product is slightly alkaline. So the vertical part of the pH titration curve is shifted upward. So we are looking for a acid-base indicator with working range higher than 7, slightly higher than 7. So phenolphthalein is a choice. Original color on here is colorless, and here comes pink. Over titration will make it red. Okay, so we would like to define the endpoint color change being from colorless to pink. From colorless to pink. Is that clear? How about number 3? C part. Calculate the percentage by mass of Tatara exit in the solid sample. Percentage by mass, which means that in that solid sample, not all containing Tatara exit, right? As said before, there are some other inner substances inside. So you are going to find out how many grams are there in 2 grams of the sample and use this data to calculate the percentage. So the answer must be smaller than 2.0 gram. Can you get my point? So you come up with that data. So how will you get the answer? So how we can approach to the problem? First of all, 做呢啲題目應該要點㗎？嗱 ，everything start from the sentence at the end. Remember, now in case we have got four lines, everything start from reading the last sentence and use this for calculations, and you project it one by one until the first sentence with number. Can you get the point? 做呢啲題目嗰陣時，第一樣嘢就係要由最尾嗰句説話開始做起，得唔得？最尾嗰句説話。Okay, so what will you get is just the neutralization reaction. So we have got C4H6O6AQ. I know it's diabetic acid, which means that for 1 mole of acid to be reacted, I need 2 mole of alkali. What we will get is the salt Na2C4H4O6. Now I change a little bit, okay, from 6 to 4. Why? Because 2 hydrogen inside are ionizable. If you say it's a diabetic acid, right? 2 hydrogen atom inside, they are ionizable. So we will get it as 2 hydrogen here and 2 hydrogen being kicked off at the same time. Can you get my point? So leaving behind, of course, we will have 2 water here. So we have 2.00 gram of something impure, and I make it the solution in 250.0 cm cube, and I extract 25.0 cm cube. So we'll use it as this. Okay. So the physical quantity is 0.122 molar, and the volume of titer is 19.35 cm cube. So I use this data to have a start. So remember, the matching of the 2 data only occurs on these 2, right? Can you get my point? These 2 would have a matching with a mole ratio 1 to 2. Okay, to start with, number of moles of the C4H6O6 in 25.0 cm cube of a solution. Now, which is exactly here, right? Which is equal to what? The 2 mole of alkaline will be used, right? So what is the hidden message? It is just the 1/2 of the number of moles of NaOH used in titration. So it is because of the according to the equation. Number of moles of tartaric acid to number of moles of alkaline is 1 to 2. Can you get my point? So that's why the alkaline should be in 2 portions. I divide by 2, here comes 1 portion of acid will be needed. Mathematically, the treatment with this. Okay, and later on, what you need to do, half times m times v, 1.22 mole per dm cube, times the volume of alkaline. So you may get it half times what? 2.36 times 10 to the power minus 3. So what is the data? Finally, it's 1.18 times 10 to the power minus 3 mole. Can you get the point? Can you get the point? So this is the one, 1.18 times 10 to the power minus 3. So be aware of the fact that you just extract 1/10 of it. So that mole of acid doesn't relate to the 2 gram, the acid found in 2 grams of the sample. It's just we represent 1/10 of it. Okay, 1/10. So you're going to do this second action. You need to project this 250.0 cm cube. You get to know how many moles of acid are there. Can you get my point? So this is our approach. So you may get it simply times 10, and you can get the answer. Simply times 10. So 250.0 cm cube of the solution. Here comes 10 times the above. Can you get my point? 10 times the above. So 1.18 times 10 to the power minus 3 becomes 1.18 times 10 to the power minus 2 mole. Can you get my point? Now, you use this data and you may go back to the gram of the acid found in the solar sample, but it's not 2.00. It's not 2.00. How do I know? So you are going to get the molar mass of of the tetrahexyl mass of C4H6O6 in the 2.0 gram of solar sample. Okay, which is 1.18 times 10 to the power minus 2 mole times its molar mass. Its molar mass is 4C6H60. What's the number? It's 150.0 gram per mole. So you may get it as about 1.77 gram. So what is the hidden message about the remaining 0.23 gram? What is that? That is something impurity, right? That means we have got 0.23 gram of impurity. So if you want to calculate that 2 gram of it, so you may get the percentage. The percentage by mass of C6H6O6 in 2.00 gram of the solar sample. It is then calculated as 1.77 over 2.00 times 10 to 100%. So here comes the answer. It is nearly 90%, 88.5%, and you have done the whole thing. You may capture the whole thing. Now for further retrieval. Questions?有冇嘢問呢度？咁啊 very authentic questions. You may find it in the past paper also. In 2016 DSE, here comes very similar questions for question 1 in the class practice. 好似嘅，2016年有條題目同呢條有啲似。有咩問？
咁我想問佢剩翻低嗰啲去咗邊啊？
剩翻低乜嘢去咗邊啊？
即係咁，佢而家係88.5% 啊嘛。
咁0.23 gram 嗰啲係乜嘢嚟嘅？係咪啊？
係咪即係喺個即係佢倒唔晒落去嗰啲啊？
嗱，嗰啲 impurities 係咩嚟嘅咧？睇清楚題目啊！第一，佢嘅 impurities 咧係 soluble 嘅。第二個 adjective 見唔見到 inert， 即係話咧佢跟住呢個 sample 入邊，佢入邊得兩樣嘢啫。第一嘅就係substance 實好多添啊，因為咧有88.5% 係酸， 跟住就喺2.00 gram 嘅 soil sample 嗰陣時咧係溶咗落去嘅，溶咗落去水度嘅。好啦，0.23 gram 嗰啲 impurity 有冇溶落水啊？都係有溶嘅，不過咧佢就同以後嘅化學反應係冇關係，所以佢就繼續留喺度，明唔明？咁我哋咧就要做啲咩咧？你要做Titration嗰時啲鹼咧，淨係同 Titrations 有反應嘅啫，就同嗰0.23 gram 嗰啲 impurity 冇任何一粒同佢有反應。咁所以佢咪會我計數嗰時咪計翻轉頭得翻1.77 gram 咯，就唔會計到2.00 gram 啦。但因為入邊0.23 gram 嘅 impurity 咧冇同佢有反應，明唔明？佢唔係沙石嚟㗎，佢係 insoluble inert substances 啊嘛，即係可溶，但係佢同其他冇化學反應啊嘛，比較穩定嘅 substances， 明唔明？所以你計咗出嚟條題目咧，就唔係計咗唔係計到2 gram， 係計到1.77 gram， 因為淨係得2 gram 入邊係得1.77 gram 嘅嘢就同佢有反應咯，明唔明？
好，唔該。
明啊，得啦 ，OK， 做咩問？好，第二條咧就係呢個啦。A student performed the following experiment to identify metal X. And the chemical formula of this hydrated oxide, which means with the water crystallization, right? It is X bracket OH2 dot 5 water. The hydroxide is soluble in water. As common practice is dissolved in distilled water, and to make the solution exactly 250.0 cm cube in a volumetric flask. I extract 1/10 of the portions and titrate it against acid. So this time acid is in the burette. Okay, it's different. Can you see the word? We'll titrate against. I use this to find, right? So the case for question 1 and question 2 is a little bit different. For question 2, the acid is found on top. Okay, so you may get about 34.00 cm cube of HCl to be consumed, while at the bottom we have got 25.00 cm cube of the solution containing XOH2. Okay, can you get my point? How about egg water? How come Mr. Chin didn't write anything? Because it's just water of crystallization. So the water of crystallization should also go with the water to form part of the solution. So there will be, you need not write down H2O here because it has been dissolved. Can you get the point? So once you draw such diagram, I do hope it will help you better understand what is happening. So no, the question doesn't ask you anything about the endpoint color change, right? So that is my question, my additional question. What is the endpoint color change? What is the endpoint color change? Dungeon A. For question 2, what is the endpoint color change? Dungeon Head, are you here?
From red
From
yellow to red, orange.
From red to orange, you mean?
Yellow to orange.
Oh, yellow to orange. Now, yeah, that's correct. Yellow to orange because the original color in alkaline media of beef orange in alkaline medium. Now, it's alkaline medium, right? It is yellow, and you add more acid to it. So in the endpoint color change, the equivalence point pH is about slightly acidic. So you stop at orange is enough. So if you use this, the endpoint color change is yellow to orange, but not red to orange, okay? Now, if I put HCl at the bottom, alkaline on top, the answer will be red to orange. But in this case, it is yellow to orange. You get it? Okay, so the question comes, calculate the number of moles of HCl required to react with 225.00 cm cube of hydroxide solution. Calculate the molar mass, and you are going to identify metal X. Now, they will be given a stepwise, right? Guided questions. And that is approach. After doing A, B, and C in that sequence, you can get the final answer is C. 係嘛？其實俾個提示你啫嘛，佢提你咯。咁會唔會考試嗰陣時咧就狼死到咧又冇 A、B、C，淨係一嚟就問你咩叫做 X 咧？係有機會㗎。咁但係呢啲咧就好誇張啦，即係一問就問4、5分咁樣。咁但係而家咧佢唔會咁樣問㗎啦，佢淨係問啲咩咧？佢俾啲 guide approach， 但係唔會 guide 得到好似而家咁樣有 A、B、C， 可能 A、B 兩 part 咁嘅樣㗎啦。可能係 A、B 會 merge 咯。Okay, so we start from A. A, what is that? Number of moles of HCl required to react. Oh, directly you write this. A and B are merged together, right? Because I just want to save some time. Now, because I write X here, OH and then 2. So, of course, X should be in 2 moles, right? In mole ratio 1 to 2. Can you get my rate of thoughts? Okay, so here comes HCl2 and 2 water, and the acid 0.350 molar, while the volume is 34.00 times 10 to the power minus 3 dm cube. So the situation here is 18.76 gram of this acid alkaline dissolved into distilled water to form 250.0 cm cube of the solution, and I extract 1/10 for calculations. So you may get these and these having a relationship, right? These two will have a relationship in a mole ratio 1 to 2. So can you get the point? According to the equation, the number of moles of the acid, first of all, okay? We start from acid. So in the titration, right? So in this XO2 hydroxide, please indicate very clearly who you are talking about in the 25.0 cm cube solution. So it's just half of that. So it is half of the molarity of HCl, okay, which is equal to 0.350 molar times volume, 34.0 10 to the power minus 3 dm cube, and here comes 12 at half times 0.0119 mole. So for A part, the answer is 0.119 mole. But if you want to calculate part of the B part here comes 5.95 times 10 to the power minus 3 mole for the 1/10 of the portions of X hydroxide. Can you get the point? Now, the same tricks that follows, it is this part. From this to this, here comes 1/10. So remember to make it times 10, and you can get what that is, okay? So the number of moles of X hydroxide in 16.76 gram of the hydroxide, which is equal to that in 250.0 cm cube solution. Can you get my point? 嗱 ，simply dissolving，right？simply dissolving， 你冇理由用完之後啲嘢少咗噶嘛？咪18.76 gram 嘅 XHO2 用落250 cm 啊嘛，咁所以咁嘅係等於翻啦，咁就係同之前嗰條式咧就爭10倍啫。So you may calculate it as this. Here comes 5.95 times 10 to the power minus 2 mole. Or the answer is 0.0595, right? I use this data to do the further calculations. Molar mass. So what is the mass of it? 18.76 grams. So you may get the molar mass. So remember this one, the molar mass of this equals to what? Now remember, you need to add H2O here. Now this, it is also equal to hydroxide H2O 係咪啊？一模一樣啊，呢兩個係一樣啊，所以咧 ，but remember the molar mass calculations, you need to add H2O here. So what is mean by that? We have got 18.76 gram. It is just the hydrosol. Now, do not get confused of the two. It's 18. H2O for this 18.7 gram. It contains 8 water crystallization per the mole of this H2O. But of course, this is also equal to the hydrated salt, the molar mass, the number of moles of a hydrated salt. 1比1，係咪？ So it is 5.95 times 10 to the power minus 2 mole. So you check the unit. So you may get the answer is gram per mole. So this is 315.3. 315.3 gram per mole. Can you get my point? So once you get this, you may also arrive at the answer is for part C. So you need to find out X. What is that? Refer to periodic table. The way to solve is to find out the RAM of X, right? So you are going to let the relative atomic mass of X be M, for example, or smaller x is up to you. So the molar mass of XO hydroxide H2O, you may get it as 315.3. So it is calculated as M plus 2, 16.0 plus 1.0 is for hydroxide, for 2 plus H2O, right? H water. So it is 2.10 plus 16.0. Where comes H18, right? H18.0. 2 hydroxide, 1 M. So you may get M. What is that? 137.3. So this is the RAM of X. So you check against the periodic table. What is that? First of all, you think it as +2 charge, right? 因為the number of moles of the cation to anion is 1 to 2, so it's +2 charge. Barium, yes, barium. That is the answer. Yep, that's right, barium. So you remember to write it for identification. X is barium. That is your final answer. 記住啊，條題目佢問你 X 係乜啊嘛？ Remember to write down X is barium as a final answer. Do not just stop at the calculations. Otherwise, the last mark will be lost. Questions? So once again, can you see the whole flow of calculations? What are the common in question 1 and question 2? Now, it seems that Mr. Chin asked you guys to do the calculations in reverse order as per the description of the questions. Do you realize? 有冇留意到？佢哋個俾嘅，佢哋睇我哋答案嘅做嘅次序咧，就同條題目嘅寫法咧係調翻轉嘅。有冇留意到？我哋睇翻頭先嗰條啊，我哋係先解決咗呢一度先嘅，呢個係第一個點，跟住漸變250乘10係咪啊？最後 project 翻19.7，跟住漸係第三個步驟，跟住最後計翻 x 價。你有冇發覺係咁嘅？而上邊條題目都好類似嘅。你計 solid sample 個 Titrations 就係點㗎？一開始就係攞 Titrations 嚟計先 ，project 翻10倍嗰個數，跟住計翻佢其實係唔係少過2 gram， 究竟係幾多 gram？ 咁啊第三點。你有冇留意到我哋答法個 whole flow 咧 ？It is just the reverse order of the presentation reverse in the questions. So I do think it will help you better understand what is happening. Questions? 有冇嘢問呢度？有冇？啊，去到呢度有咩問先？冇嘛，冇咧，咁我哋就嚟個簡單嘅 consultation，instead of 開新課啦，因為得翻3個字啫。咁我哋 consult 落地翻我哋啱啱講緊嘅嘢。如果唔係咧，你哋就會好混亂㗎啦。做 MC 啊，做 MC 嘅第11、12同埋13。MC 11、12、13 on page 141. 141. 15做住，因為講緊 conductivity，一陣再解。下堂先啦，11。A student carry out a titration, any of which is transferred to clinical flask using a pipette. Beta orange is added to the flask, and then HCl is added from the burette until the indicator changes color. What would the following would lead to the titer being larger than it should be? 咦，咁似佢講緊咩啊？高估咯，係咪啊？邊個 case 係會有高估嘅現象 ？A、B、C 嗰啲，甚至琴日問嗰啲嘢嘅喎，高估。好，有問答到邊個係高估？
係咪應該係 B 啊？係咪應該係 B？Boy，
好，解釋下 boy。
因為佢洗咗個 burette 嘅時候咧，咁 hydrochloric acid 再加入去嘅時候就會稀釋咗嘅，咁佢稀釋咗嘅時候，即係個 hydrochloric acid 會俾人稀釋咗，所以就要加多咗 hydrochloric acid 落去先可以稀釋，即係先可以 neutralization 到，所以佢就係會高估咗。
係啦，啱啦。咁因為咧，我哋個讀數上邊咧，我哋依賴讀數去計數噶嘛。咁個讀數咧就因為嗰個酸溝稀咗咧，你不自覺地你加多咗嘅，用多咗個名啊，個讀出嚟個讀數用多咗。More HCl needed for titration 係咩咧？係 more recorded volume。嗱，留意下啲字眼，我哋係咪用多咗冇啊？喺讀數上用多咗咧， So you more recorded volume of HCl is needed for titration. So it will lead to the overestimation of the results. So the titer being larger than it. Okay. So remember the recorded volume. So we call that volume of titer is larger than expected. How about A, C, and D? How about A, C, and D? A, any effect? What is the effect? Rinsing the conical flask with water before adding the sodium hydroxide solution. How does it affect titer? Will it become larger or smaller? 有咩影響？琴日你話大家都答到頭暈腦脹，就係呢啲係咪？鄭學明 ，for A， 鄭學明
係
，take a look on your choice A。What is the effect of A on the volume of titer? Larger, smaller, or what?
Smaller.
Smaller. Why?
因為嘅 NaOH 減咗，咁樣你落嘅 HCl 落去 neutralize 嘅話，都個 volume 都會少咗。
NaOH 少咗啊，原本。
唔係
你 NaOH 攞啲咩嚟 ？NaOH 冇咁鹼啊，所以就落少啲酸，係咪啊？即係因為啲鹼溝起咗，所以冇咁鹼，所以就攞少啲酸就可以 neutralize 晒啦，係咪？係咪意思啊？哦。咁我有乜嘢去斷定要加幾多酸落去啲鹼度咧？係講緊佢個 pH 值啦，定係睇 mol 數咧？就睇 NaOH 個 mol 數咧。就明 which determines the number of moles of hydrochloric acid that is needed to react with the alkaline. Is it the pH of the solution? Concentration? Number of moles of or number of moles of NaOH.
應該係咪 number of moles?
Yes, number of moles of the NaOH. How about the conical flask? Once I rinse it with water, of course, more water can be found inside the conical flask. Would it affect the total number of moles of NaOH inside the conical flask? Now, so remember, what glassware is used to deliver NaOH? Is pipette. But the one to contain the final solution is in conical flask with more water there. Would it affect?
呢個應該係冇影響。
Yes, that's right. The answer is no effect. Okay, for A part, the answer is no effect of the volume of titer. So you remember the logic is not just overestimation, underestimation. It can be no effect. For A part, no effect. How about C? Rinsing the pipette with water before filling it with the sodium hydroxide solution. What is the effect?
Underestimation 啊，呢個係。
Underestimation. Why? Why?
因為啲 sodium hydroxide 會dilute咗。
Sodium hydroxide 會dilute咗。你睇清楚條題目講咩先 ？Rinsing the pipette with water before filling it with sodium hydroxide solution。即係話用佢係未放 NaOH 之前溝稀咗係咪啊？溝稀咗 ，so the less number of moles of NaOH will be containing in that fixed volume of a solution in pipette. So of course you need less acid for titration, so it's underestimated. Okay, under. no effect. Can you get my point? How about adding extra drop of indicator? The answer is also no effect. Okay, the answer is also no effect. So the same answer. How about question 12? In an experiment, 呢個12。
咁我想問，咁如果係 titration 嘅話，咁係咪即係代表你加幾多滴嘅 indicator 都冇所謂？
good question. The answer is 有冇人答到？係咪要加好多啊？加好多都得，係咪啊？嗱，it really depends on the nature of indicator. Now, there will be some examples where the indicator will not just having a reversible reaction with the indicator. So indicator, the chemistry of indicator, it is done by a concept of having it as an equilibrium. So what is mean by that? The exit base indicator equilibrium. So if you say such, what is that? You are going to have the equation like this, and yeah, here this is the one. With the acid-base indicator, it's just the indicator having a wet exit. In this wet exit, we will go to the reversible reaction to release hydrogen ion and the anion of the indicator form. And each form will have this color. So they will have this working range. So that's why you may see that very often the working range of it is about plus or minus 1. Okay, why? Because it is related to the exit, the equilibrium constant of the exit itself. And why would I say that is blue color is a dominant color? Now it depends on how much relative concentration of the blue color overwhelms the yellow. To our human senses, about 10 times more from each other, we will say the color more dominant. What do I mean by that? You find that the blue color, the blue anionic form of the indicator is 10 times more than the exit form, is yellow. Why we say the solution is blue. In reverse, it is yellow. How about in between? In between, that is just a mixing of a yellow and blue. So I will read it as green. So that's why you may see that mid orange is red, and then orange middle color is orange, right? Red, yellow, and then orange in the middle. It's just a mixing of red and yellow. Now go back to the questions. So in this sentence, if I add more acid, more alkaline, no problem. So the reaction will go, and you will go back to the normal form. So theoretically, the addition of certain amounts of indicator doesn't affect the accuracy of the data. However, there are some other cases in which the indicator will react with highly acidic or highly alkaline medium. For example, phenolphthalein。你記唔記得有一次你哋做實驗嗰陣時咧，有冇留意到 phenolphthalein 咧？佢係會同 hydroxide ion 咧 react 嘅。我點樣 react 啦 ？It reacts as a somebody would say that it reacts with the from pink color， 記唔記得？但係咧，我記得咧嗰一次嚟睇堂咧，我就發覺咧有同學就問啦，阿 Sir 啊，點解咧我見到嗰啲 phenolphthalein 咧，你明明加咗鹼係粉紅色㗎嘛？點解啲粉紅色一逐一聲咧就變咗做冇色嘅？你有冇留意到？嗱，原來咧 phenolphthalein 咧係一個係 strongly alkaline medium 嗰陣時咧，佢係會有 reaction 嘅，而個 reaction 就唔係頭先我哋講緊嘅 reaction。咁我會導致到啲咩咧？就導致到嗰個 chemical 原來佢自己 consume 咗，嗱翻唔到轉頭。嗱，如果係呢個 case 嚟講咧，你加 indicator 多與少咧就係關鍵啦，你唔可以加得太多，係會有化學反應嘅，得唔得？所以頭先回應翻阿特號像問題，個答案就係、其實咧你應該係落3到5滴就夠㗎啦。你使唔使落1 ml 啊2 ml 係唔需要嘅，得唔得？你攞太多反而係會有引發緊其他嘅化學反應。第二， 喺每一次嘅 titration 入邊，你係咗個 consistent result 啫嘛。點整 consistent result? We rely on the color change. So every time, whenever you should do it consistently with the number of drops of indicator to be added as well. Our common practice is 3 to 5 drops is enough. OK 得唔得？所以咧你要搞清楚啦。頭先條問題咧個 assumption 就係 indicator 同酸同鹼有乜嘢化學反應？嗱，如果係 equilibrium 嘅 ，it's reversible, no problem. But if you have got lead to some other irreversible reaction, sorry, no, it's something problematic. OK, I do hope this will help answer the questions. 好，仲冇嘢問？豆咗你仲未問呢度？
冇啦，冇，好唔該。
明啊？明發生乜事啊？好啦，咁我哋去翻，咦？頭先嗰個版去邊？死啦！係咪呢度？去翻啲 MC 先。咦？唔係呢份嘅喂。好，去到 last 啦，12、13。話唔夠時間啦，就係12、13。我唔見咗頭先個版。唔緊要咯，12、13個答案係咩咧？呢個咩？我咪頭先交叉咗嘅啫，揾唔翻你咪做啦。唉，12呢度，好12，你會答到啲咩咧？係呢度12。In experiment, 10 cm cube of 1 molar sulfuric 呢條were mixed with 30 cm cube 1 molar potassium hydroxide solution. Which of following statements concerning experiment is all correct? 好 ，A、B、C 嗰啲。好，有人話答 B，B 得呢個答案係啱嘅啫。點解咧？第一 0.101 mole of what is produced is wrong. Why? You are going to stick back to the equation. You're going to stick back to the equation. So you may get it as KOH is calculated as how many moles? How many moles of that?
0.03 KOH。
0.03，但係咧酸咧就係幾多？0.01，咁即係邊個 in excess 啊
？KOH in excess。
KOH in excess 啊 ，KOH in excess, which means that the solution is alkaline. That is point number 1. Point number 2, that data is not reliable, right? Go back to the number of moles of water before. 1 to 2 mole ratio. The number of moles of water to produce is 0.02. 係啦，所以呢個答案係錯嘅。How about 3? After water is completely evaporated, the pure crystal thing is wrong because it will have got some residue of the alkaline, right? So it's not pure. The answer is B. Last questions. 13. 問到好多次㗎啦，攞咩洗啊？淨係攞水洗 ，only 啊 ，only 咩啊？邊個？
即係用 burette 咯。
burette 淨係 Brett 淨係攞水就得啦。錯咗啦 ，Brett 錯。
調轉咗
Brett 錯23啱啊！因為 conical flask 咧已經係你之前身你攞個排 pad， 總之係排 pad 準就得啦，係咪？排 pad 遞落去個準，所以 conical flask 唔應該有其他嘢，所以要洗乾淨晒，明唔明？第二 volumetric flask 咧之前係你攞嚟 contain 250.0 cm 嘅 solution 嘛，我理得你攞鹽開啊，加水整溶佢啊，或者係溝稀10倍嗰啲都好啦。你本身最準喺前邊已經做咗啦嘛，所以就個 container 咧就唔應該有其他嘢喺度嘅，所以淨係攞水沖就得啦。明唔明白 ？get 唔 get 到成個邏輯喺度？明係嘛？好，我過埋金堂啦，會唔會好少少？琴日就話俾我聽咧，好恐怖啦，好多人都得個5啫。咁今日咧就冇啲。嗱，唔需要太過擔心啊，因為呢啲 exercise 咧，我哋會慢個路做噶啦。嚟緊 day 5啦，下個禮拜 day 1啦，同補課呢慢咁路做。即係做到識為止啊。黃奕朗係咪 attention seeking 啊？你睇個3字想寫啊？唔係真係要做多啲嘅呢個，得唔得？係啊，啱啊，唔緊要啦，暫時都係5，繼續做到識為止。考完試放完假翻嚟之後就測驗，令到你哋明啲。好，講住咁多先，下堂 day 5堂，拜拜。